Okay, I will split the video to two parts, which are reviews at 11a and reviews at 11b. If we are finding the average rate of change, so what we need to find is the gradient. The gradient from A to B is this formula. So mention the point A and B, right? X, y. And the gradient, which is x sub x, 1 subtract -3, 2 subtract -1. And for number 2, is the ski lift increasing in height at a constant rate? Of course, yes. Explain your answer. It follows the linear equation by increasing the time follows by the increasing of the height. Wait, look at the key points. The rate is always gradient. So you can pick any point, 0, 0, or another easy point. I think you can look at here, right? This is an exact number. 125, 200. So we move the gradient or the rate will equals to 200 subtract 0 over 125 subtract 0. We can make it simple. Divide by 25 and over 5. Right? So 1, 3 out of 5. You can choose either one of it. Okay, I will copy paste the file and we go for number 3. Let's do number 3. Okay, so if you are asked to find the limit, what you need to do is try to insert the x1. 6 times 1 subtract 7 is 6 minus 7, -1. But for part B, there will be a special case where the limit cannot be 0 over 0. This is error. So what you need to do is try to solve until you don't get the 0 over 0 anymore. If you put like this, it will be 0 over 0. It is prohibited. Why? Because actually h is not equals to 0, but h is near. So there will be a specific value. So you can do the factorization. So if you factorize this, you can get rid of h. So 2h subtract 1 over h. You cross out the 0, then you can insert h equals 0. Okay, and we get -1. Part C also, if you insist to put the 4, we will get this, right? And this also a 0 over 0 thing, and it is prohibited. So what you need to do is try to factorize. I can put 16 as whole square, and you can factorize by the formula of a square minus b square equals a plus b, a minus b. Then you can separate the x square minus 4 square. And then you can get x minus 4, cross out. So you get the answer, x plus 4, and you insert x equals 4. You get 8. Okay, next. number 4. Like this. For number 4, we have to draw the graph. First thing first, you need to understand the behavior of this graph. So for question A, you can put you have to understand about the asymptote, where the formula will be like this over cx plus d here. So this will be the horizontal asymptote. The formula of the horizontal asymptote, y equals a over c. And there will be some prohibition, which is called the vertical asymptote, where x equals, or cx plus d equals 0. Here we have two formulas here. Then let's try to solve for question A. Y equals, we can put it like this, right? By ordering to follow this kind of understanding. Mention the horizontal asymptote. Y equals a over c, 1 over 1, y equals 1. Where the vertical asymptote here, let's follow the formula. X minus 4 equals 0, x equals 4. Then let's sketch the graph. X equals 4. 1, 2, 3, 4. This is what we call the vertical asymptote. And y equals 1. This is what we call the horizontal asymptote. Then what you can do next is try to put any points. Okay. So with this formula, try to pick any points. So let's say I want to pick x equals to 1, say. So I put y equals to 1 plus 2 over 1 minus 4. So 3 over negative 3, negative 1. So we have the point 1 comma negative 1. Like it here. So it has to be like this. And this also. Then we can discuss the behavior of the graph B. I think I better delete 5. Then you can go to 4 B. As it is seen on your graph, when it is near to the asymptote, it will never touch the asymptote. Okay, that's it. And the equation is already given. Y equals 1 and x equals 4. Where do I get that? I get it from here. Okay. See, if you put x as negative infinity, if you put x as negative infinity here, it's equal to 1. So what happened? It will never reach the horizontal asymptote, but it will be always near to the horizontal asymptote itself. So the y will near to 1, right? Go up, up, up. Okay, go up as always. Part 2. When the x is to the infinity, positive infinity means that it will reach 1 also, but always above. This also, but always less than, right? Below 1. Cannot be more than 1. That's the formula of question 4. And so for number 5, it's quite challenging. So we have fx equals 2x squared, and we are asked to find fx plus h. So you have to find the x plus h first. As a function, the function so follows this rule, square, right? So just take the x as x plus h. And part A, we can just do slowly. I just copy paste the question. Equals. So what is fx plus h? Here, minus 2x squared over h. Then you can simplify the left side. You can just put like this. Yeah, I hope you understand what I do. Over h. Okay, and then we can expand like this, right? 1 over 5. You can cross out the 2x squared minus 2x squared, and you can factorize top 2h bracket 2x plus h over h. And you will get simple formula and proven right. There you go. See, proven. Now question B. Evaluate f3h, 3 plus h minus f3. Okay, over h. So you just simply put like this. So for x minus plus 2h, which means 4 times 3 plus 2h, 12 plus h, right? This is for part B. And complete the table. If h equals 0.1, you can just write 12 plus 0.1. This is 12 plus 0.01. This is 12.001, and so on. Done. And evaluate if h is near to 0. So if x is near to 0, the value of 4x plus 2h is 4 times 3 plus 2 times 0, right? If h near to 0, which means the gradient is near to 12. So for part C, you can conclude that whenever it reaches near to 0, the gradient will near to 12. That's the formula. Here, to find f accent means gradient. When accent 3, it means that the tangent passes through 3. This is a tangent, so what you need to do is try to find gradient. The tangent of line passes through 0, 4, and 8, 0. So you just write the formula, gradient formula, 0 minus 4 over 8 minus 0, which means negative half. That's all. Simple. Okay, so f accent is equals to gradient. That's for your memorize. Let's go number 7. Okay, first principle of derivative is quite easy. So for number 7, I have y equals a to the power times x to the power of n. The dy dx, which is the derivative, is equals to a. You put the power below, and x, you put the power below, subtract by 1. So for 7a, it's very simple. So the dy dx equals to 2 put below, x power 1, 2 minus 1, which is 2 itself, to x itself, plus 2. Okay, I will do it one by one slowly. Plus 2 times, this is 1, 1 minus 1. So you will get the answer of 2x plus 2 itself. Done. How about 7b? Also the same. 1 minus 3x power 2. So actually, if we have the number, if we want to derive a constant, it will get 0, right? So 0 minus 3, you put the 2 below, x power 2 minus 1. So you can get negative 6x. That's it for question 7. How about 8? Let's see. Y equals to x squared minus 1. So the dy dx equals to 2 times 2 x power 2 minus 1 minus 0, right? So equals to 4x. Done. Hence, state the gradient of the tangent. So the gradient of the tangent is always equals to the dy dx, or the first derivative. So where x equals 4, the m equals 4x, which is 4. Put it here. So you will get 16. So for what value, let's see, for what value of x is the gradient to the tangent of the previous equation, x equals to negative 12. So the gradient is actually negative 12. The gradient is already 4x, right? As always, 4x equals negative 12. So the x will be negative 12 over 4, which is negative 3. Done. We're going to go for last question, question 9, on the other place. I think I'll delete this first. No need. Oh, wait. 9. Number 9. Okay, the graph of fx equals x cubed minus 3x squared is shown in the table alongside. So how do you derive? So I think this is the first derivative. So you derive 1 by 1, 3 x power 3 minus 1, make it plus, minus 3 times 2, 6 x power 1. That's it, or 6x itself. Show that the illustrated tangent are parallel. So the illustrated tangent are parallel by looking at the x. So f accent negative 1 and f accent 3. So the first derivative when x equals negative 1 and the first derivative when x equals 3. Let's see. And it has to be equal because the tangent has to be equal. Over here, we will get 3 times 1 minus plus 6, 9. And this also 6 times 3. So this is 3 times 9, 27, 18, 9 itself. So it is proven. You have to understand that When you reach the equal gradient, when the gradient is equal, it means that it is parallel. It's proven, so we are done for, we are finished for previous A.